Hello everyone and welcome to NCERT Flicks. Today, we are going to dive into one of the most fundamental forces in the entire universe. I mean, this is a force that's responsible for, well, pretty much everything, from that tiny spark you see when you pull off a sweater, all the way to the actual thoughts firing in your brain. We are talking about electric charge. You've totally been there, right? It's dark, you're taking off a sweater, and you see these little flashes of light and hear that faint crackling sound. Or what about that little zap you get when you touch a doorknob? So what is actually going on there?
Well, in this explainer, we're going to pull back the curtain on that whole mystery. We'll start with that everyday spark, and then we'll properly meet the culprit behind it, electric charge. We're going to see how it travels through some things but gets stopped by others. We'll uncover its 3 unbreakable laws, and we'll wrap up with a fact about charge that's hiding all around you that is seriously going to blow your mind.
Okay, so that little spark and that crackle from your sweater, that's all thanks to something called static electricity. The static part just means the charges are kind of sitting still until, boom, they're not.
And here's the crazy part. That tiny, totally harmless spark from your sweater and a massive, terrifyingly powerful bolt of lightning, they are the exact same thing, just on a wildly different scale. Both of them are just a sudden release of built-up electric charge.
So what exactly is this charge that's building up and causing all this ruckus? Let's finally meet the main character of our story.
You know how matter has mass, right? It's just a built-in property. Well, electric charge is just like that. It's a fundamental, built-in property of matter. But while mass deals with gravity and how heavy something is, charge determines how things interact electrically. It's the source of this whole other world of pushes and pulls.
And what's amazing is how simple it is. In the entire universe, there are only 2 types of electric charge. That's it. And we can thank the brilliant Benjamin Franklin for naming them positive and negative. He picked those names for a really smart reason. He saw that they cancel each other out, just like adding a +1 and a -1 in math gets you back to 0.
And these 2 charges follow 2 super simple golden rules. First, like charges repel. They push each other away. So a positive charge pushes another positive charge away, and negative pushes negative away. But, and you've probably heard this one, unlike or opposite charges attract. They pull towards each other. This simple push and pull is behind almost everything.
Okay, this is a really crucial point. How does something even get charged to begin with? Here's the secret. You don't create charge out of thin air. It's already there. All you're doing is moving around these tiny negative particles called electrons. So if an object loses some electrons, it's left with more positive stuff than negative stuff, so we say it becomes positively charged. And if it gains some extra electrons, it becomes negatively charged. It's all just a transfer game.
Now, it turns out that not all materials handle these moving charges in the same way. They pretty much fall into 2 main groups.
On one side, you have conductors. These are materials where electrons can just zip around super easily. You can think of them like a wide-open highway for charge. And on the other side, you have insulators. In these materials, the electrons are held on really tight and can't move around. They act like giant brick walls, completely blocking the flow of charge.
And you deal with these every single day. Most metals, like the copper inside your phone charger, are fantastic conductors. Fun fact, your body is also a pretty decent conductor. Insulators are things like the plastic or rubber coating around that wire, or a glass cup, or a wooden table. They keep the charge from going where it's not supposed to.
Now this all leads to a super important safety idea called grounding, or sometimes earthing. See, the earth is so huge that it can basically act like a giant sponge for electric charge. It can soak up or give away a massive number of electrons without even blinking. So if we connect a charged object to the ground, all that extra charge just flows safely away. This is exactly what that 3rd round pin on some electrical plugs is for.
Hey, just a quick pause here. If you're finding this whole breakdown of charges and materials useful and you want more physics lessons made simple and clear, just like this one, do me a favor and hit that subscribe button for NCERT Flicks. It honestly helps us a ton.
All right, so now we know what charge is and how it can move. Let's dig a little deeper into 3 fundamental properties that it always follows. Think of these as the unbreakable laws of the electrical universe. The 3 big rules are additivity, conservation, and quantization. They might sound a little fancy, but let's break down what each one really means.
First up is additivity. This one is pretty much what it sounds like. It just means that if you have a bunch of different charges in one area, the total charge is what you get when you just add them all up. But here's the catch.
Unlike with mass, you have to pay attention to the plus and minus signs. So a charge of +5 and a charge of -3 adds up to a total charge of +2.
Second, and this is a huge one, is the law of conservation of charge. This law says you can never, ever create or destroy net electric charge, period. In any process, the total amount of charge you start with is the exact same amount you end with. So when you rub a plastic rod with fur, you're not making new negative charge on the rod. You're just moving electrons that were already there from the fur onto the rod. The total charge of the whole system doesn't change one bit.
And third, we have quantization. Now this one is a little weird at first, but it's incredibly cool. It means that charge doesn't just come in any old random amount. It only comes in tiny, distinct packets. The smallest possible packet of charge has a name, the elementary charge, and we represent it with the letter E. Any amount of charge you ever find in the universe is just a whole number of these little packets.
Here's the best way to think about it. Imagine you have a bag of chocolates. You can have 1 chocolate or 2 or 10, but you can never have 2.5 chocolates, right? It just doesn't work that way. Well, charge is exactly the same. You can have the charge of 1 electron or 2 or a billion, but you can never, ever have the charge of 2.5 electrons. It only comes in whole numbers.
So we've learned that all this stuff around us is packed with positive and negative charges that are usually perfectly balanced. Let's finish up by looking at just how much charge is hiding in plain sight. Take a good look at this number. That's 13.4 million coulombs. A coulomb is just the unit we use for charge. Now, get ready for this. That is the amount of positive charge and an equal amount of negative charge that is crammed into a single 250-gram cup of water. The electrical forces inside that cup are absolutely staggering.
And that brings us to our final, mind-bending question. If every cup of water is sitting there with this unbelievable, astronomical amount of electric charge locked inside it, why don't we feel anything? Why is it just a cup of water? Why is it electrically neutral? The answer is the perfect summary of everything we've talked about. Think about that.